In this lesson, let's look at free fall in slightly from a slightly different perspective. So free fall, and this time the example I want to take is an example that we worked. Here is a basketball floor. This is z equal to 0, and a player jumps straight up, and the maximum height she reaches is, z max equals 1.0 meters. Z max is 1.0 meters. How did that happen? It happened because the player started here, had an initial velocity of v0 that propelled her to go up there. Just as the other day, I threw something. I add. Where am I? Okay, I don't see it. Initial velocity given, object move up. So initial velocity given went up. How long did it take the jumper to reach there? Took some time. I think in the worked out problem, we found something like 0.3 seconds, or 0.25 seconds, whatever, some number. So I'm going to say time to reach. So right here, starting time, t equal to 0. Up here, t equal to t max. T equal to t max. It has a value, but I'm going to symbolize it with t max. So as the jumper started with, I think we found 3.74 meter per second velocity. As she was going up, slowing down, all the way up, stops. Then starts falling. What time does she hit the ground again? At 2 t max. So 0 time to t max is to go up, then t max plus another full t max to come down. So how do I visualize it? And what is happening all this time? We know for certain all this time a sub z equals minus g earth equal to minus 9.8 meter per second squared. All this time from t equal to 0 to t max to coming back to again to t max to 2t max. All this time, acceleration of the jumper is still downward at this rate. So how do I express that? As a graph. So I'm going to draw a graph. This is called x-axis or horizontal axis. Horizontal axis. Axis. Or independent variable axis. So this is where I will draw time. What about this? This is where I'm going to draw a, or a sub z. But a sub z value, if this is plus 10 meter per second square, actual value is minus 10 meter per second square. So exactly right here is minus 10 meter per second square. So when is the time starting? Time t equal to 0. T equal to 2t max. Right here is t max. What is happening here? At this point, the jumper is all the way up. At this point, jumper is back on ground. But all this time, what is the acceleration of the jumper? Its acceleration of the jumper is downward 9.8 meter per second square. 9.8 meter per second square is the acceleration of the jumper all through this time. Okay, so we see acceleration is the same constant value. What about the velocity of the jumper? I want to look at the velocity of the jumper. So I'm going to do another graph of what's happening with the velocity of the jumper with time. So let me draw this. Now again, time axis would be horizontal axis. Time axis is horizontal. Time axis is horizontal. Time in seconds. And up here now, not acceleration. This is the y-axis, the dependent variable axis. This is v sub z, velocity of the jumper in the z direction. So at time t equal to 0, the velocity of the jumper was v0 z. And the other day when we're doing the problem, I think we found it is plus 3.74 meter per second. So right away at time t equal to 0, jumper is moving up at 3.74 meters. What is the mathematical relationship between v of z and time? V times z equals v0z minus gt. So as far as velocity is concerned, it depends on time. Acceleration doesn't depend on time. Acceleration is always minus g. So let me write this down. v0z minus 9.8 times t. So this relation, v of t equal to this, tells us how v changes with time. So at the beginning, at t equal to 0, vz is 3.74 meters, let's say. What's going to happen next instant? Next instant is going to be changed by, due to the acceleration downward, v will be less than what it was before. V was plus 3.7, it will be less. Until when? Until when this term is exactly 3.74. I can recalculate and see what that is. 3.74 divided by 9.8. Yes. So right here, when t equals t max equals 0.382 seconds, velocity has come down to 0. So velocity started at 3.74 meters. Now as time goes on, velocity comes down at exactly the value of time equal to 3.82 seconds. Object comes to a halt. Object is up here. Object has reached the maximum point. It's not moving up anymore. It's not moving down anymore. That instant velocity is 0. What happens next? This formula continues. So velocity now would be negative because starting with 0, negative. So velocity would go down like this until it is minus 3.74 meter per second. 3.74, exactly same value but downward when it hits the ground. Time equals t equals 2 times t max, which is 2 times 0.382, which is times 2 equals, so at time t equal to 0.763 seconds, object reaches the ground, touches the floor, motion stops. So let's recap. How does acceleration go? Acceleration is at all times minus 9.8 meter per second squared. There's nothing there. What about velocity? Velocity starts positive, big value at the bottom, right when the player takes off, moving fast, 3.74 meters, but rate of motion becomes smaller and smaller. It's being decreased by downward acceleration, decreased by downward acceleration. Then exactly at t max, maximum height, time equal to 3.82 seconds, motion stops. Object doesn't move anymore, starts falling. And it takes same amount of time to reach the ground. So we now see acceleration is constant, but velocity is doing different things. Acceleration always downward, velocity is not always downward. Now let's look at what's the position doing. Position is